early days of geometry, back in the times of Pythagoras and Plato, the idea was developed that the Platonic forms were real, even though they existed only in the mind. Right. Truly, that there was a reality to it. And now we can look back thousands of years later and see the contributions of generations and generations of mathematicians. And now we have a mathematical structure like the original Platonic forms, only it's incredibly, vastly more complex. It incorporates many, many dimensions of space, 9 dimensions of space, 1 dimension of time, as you have mentioned. It seems to explain the most fundamental pervasive and powerful theories we have of physics. So it's as if there is this huge structure, mental structure, and that it is becoming a powerful reality in our lives.
Yes, there are many different aspects to explore that very issue. I mean, for one thing, from the physics alone, the superstring theory has evolved into, in the 80s, it evolved into 4 or 5 different fundamental superstring theories, and that was an embarrassment to string theory because they all seem to work in one way or another. One would work better for some aspects of physics and some for other aspects of physics, but now actually a very recent breakthrough in superstring theory is going back only to 1994. That's very recent. Now we know that there's an overarching superstring theory, which they call M theory, for membrane magic or mystery, according to the physicist's taste. And this overarching string theory even has these 5 or 6 different string theories as, in a sense, sub-theories of it. And so the job of the string theorists today is to understand this M theory that they call. Okay, that's on the physics side of it. On the mathematical side of it, some of the basic tricks that the physicists use to do the mathematics of string theory have been grabbed from what they think of as a mathematician's grab bag, except it's not so much a grab bag because there's a tremendous unification of mathematics taking place in mathematics. The kind of unification that occurred when Descartes made a fundamental connection between geometry and algebra, that those kinds of unifications have taken place in mathematics ever since then, but there's a really phenomenal unification is taking place in mathematics that's very difficult to describe without pictures and diagrams and so on. But suffice it to say, one of the most fascinating and mysterious and wonderful things about it is that it entails the Platonic solids playing a fundamental role. And so the mathematicians working on this mathematical unification have kind of become super Platonists. In fact, a Russian mathematician who's played the biggest role perhaps in this unification, a fellow named V.I. Arnold, who's a very great mathematician, as all mathematicians know, he calls this area of mathematics, this unification of many different areas of mathematics, he calls it Platonics.
And I think what you're suggesting is that this new field of Platonics and hyperspace Platonics, that is likely to affect our lives in the coming decades as much as the equations of Maxwell back in the middle of the 19th century generated vast new realms of technology for the 20th century, things that Maxwell himself couldn't have envisioned. One more point. Though we've talked so much about string theory, and I think we owe it to our viewers to try and explain why is it called string theory. My best guess is, what I gather is that it's suggesting that all of the fundamental particles of physics are oscillations like a string vibrating through 9 dimensions of space or 10 dimensions of space-time.
Yes, in quantum field theory, which was the basic theory of which and still is the basic theory of the particles. Remember when I said that there are matter particles and force particles in quantum field theory? The basic matter and force particles are considered geometrical points. They're simply points. Okay, and so when they change position, in other words, we think of them as tracing out a line in space-time, and we draw things called Feynman diagrams, which are these points tracing out lines and exchanging particles, but you see nothing but lines intersecting lines in a Feynman diagram. And so the string theory idea is to introduce a fundamentally new concept, which is that points aren't fundamental things, that the fundamental things are little rings, little circles that we call strings, okay? Because they're one-dimensional objects that are a circle. We think of a circle as not the disk I'm talking about the rim of the disk. That's a circle, and it's a one-dimensional object. And
curving
back on itself, just a circle. And that's the fundamental object, and there's only one type of fundamental object. There's not a whole zoo of hundreds and hundreds of particles now. They're just circles, okay? And what these circles do is they bang into each other and create larger circles. In other words, they join up and then break apart and break and join in a complex dance. And the dance is very complex because they're not doing this in 3 space, but they're doing this in a 9-dimensional space-time. Okay.
Or 10-dimensional space-time.
10-dimensional space-time, I'm sorry, in nine dimensions of space. And so instead of sweeping out lines like you see in these Feynman diagrams, point particles sweeping out lines, we think of these strings in their complicated dance sweeping out surfaces like a very complicated drum head. Okay, and then we think of this we call that the world sheet in string theory rather than the world line that we use in Feynman diagrams. Feynman diagrams consist of world lines in space-time. So now we have, in 4-dimensional space-time. So now we have a world sheet in 9-dimensional space-time, but the sheet is vibrating. And it's vibrating in a very complex manner. And these vibrations are, the harmonics of the vibrations are the particles.